Hi everyone. Our topic this week is called the thermal envelope. We'll start out by discussing what the building envelope is and how heat is gained and lost through that envelope. We'll talk about thermal resistance, insulation, and R values. We'll spend a little time calculating some R values and some thermal resistance, all right, and finish up with a discussion on windows. The building envelope is the shell or enclosure around the internal space, and that's specifically the internal conditioned space or heated space. All right, so it's every part of the construction that separates heated space or indoor space from unheated space. Right? For example, a wall in between a living space and the exterior, the outside, would be part of the building envelope. Okay. Also, a floor in between a living room or a heated space and a unheated crawl space would also be part of the building envelope. Heat is going to flow in and out of this building envelope. And it's important for our energy conserving goals. All right, we've been talking a lot about sustainability this semester. It's important that the building envelope exclude the heat, keep out the heat in the summer, and retain or keep in the heat in the winter. So let's talk about some of these sources of heat gain and loss. And they all happen through convection, conduction, and radiation through that building envelope. Solar radiation on glazing or glass through your windows is going to add heat. All right. Infiltration of air or required ventilation is going to cause heat gain or loss. And finally, building occupants or equipment. All right, we people who live inside of buildings are great producers of heat. All right, and will cause heat gain for your building. So here are some illustrations from your textbook. And on the left, we have a building that is warm inside, okay, and cold outside. Perhaps this is winter. All right. And so some sources of heat loss are ventilation. When we ventilate air to the outside, that heat goes with it. All right. And it says transmission. That's going to be your conduction of heat right through the building walls and floors. All right. Finally, there's going to be some radiation of the heat through the glass. Moving on to the right-hand side, here we have perhaps a building in summer. It's got cool air inside and warm air outside. And how is it gaining heat? We want to keep the heat out. It's gaining heat from the people and appliances and light fixtures all inside. Those all produce heat, right? It's gaining heat from radiation right through the window. Right? It's gaining heat from conduction through the walls, right, and through the roofs, right into the space. And finally, it's gaining heat from infiltration when hot, moist air sneaks into the building. A little flashback here, the materials that we make our buildings out of oppose the flow of heat through them. And that thermal resistance is going to vary by the type of material. Some type materials are better insulators and some are better conductors. And so we measure this thermal resistance with R value. Higher R value is more thermal resistance, lower R value is less thermal resistance. Which brings us to the topic of thermal insulation. Thermal insulation controls the flow of heat through the building envelope. All right, it prevents heat loss and also heat gain. All right, it works both ways. It'll keep your building warm in the winter and cool in the summer. And therefore, thermal insulation reduces your energy requirements for your building. All right. Now, your textbook goes to great detail of information about the different types of thermal insulation. So I invite you to go explore that section on your own. Okay, that was an introduction to the thermal envelope of a building and how heat passes through the thermal envelope for heat gain or heat loss. In the next video, we're going to continue on to find out how to calculate the R value for the construction of your thermal